Hi, my name is Refentse Molehe. I am a process engineer for the gravity division at Multotec. So today I will be discussing with you our new spiral, which is called the UF7. So in this image, what you'll see is that I've placed the different forms of earphones that you can get. So what I want to emphasize with this picture is that just like Apple takes years to develop new products, that's the same procedure we take at Multotec. So you will see that there is, at 2020, we have the new UF7. And I'm so excited to share with you the new developments that we have made for fine chrome. So like I mentioned, the UF7 is the new spiral that we have introduced. For many years, when it came to ultrafine processing, we always recommended our great spiral called the HX5. But what we realized is that it had its own limitations. So we are very intentional about developing a new product that is able to specifically handle material that is below 75 micron. Typically, what has happened when it came to treating fines is that whenever you put in a material that's obviously with spirals, you have a top size of 1 millimeter. We always recommend, and industry actually recommends, that material that is below 45 microns or 38 microns needs to be removed to improve the efficiency of the spiral. So the rule of thumb is that if you have a cumulative passing at 38 microns that is more than 10%, we recommend desliming. So what you will notice in this image is that this is an analysis that we have done on the desliming material of the underflow. So when you look specifically at the minus 38 microns and you look at the chrome grade, you find that the material is still quite high. But what typically happens on a spiral is that when you have material below 45 microns, it reports to the side, which is referred to as slimes, and that reports actually towards the end of the spiral trough. If it's towards the end of the spiral trough, you expect that it will be collected with your tailings, and that means it can end up being part of your discard. When we did further analysis specifically of the spiral tails, you find that the grade of the material, the chrome grade specifically, can range, for example with this client, can range between 27% and 30 or 39 or 40%. But that's relatively high, and that is actually what you refer to as your chrome grade. But because the HX5 spiral or any other spiral has struggled to push this material towards your concentrate, this is a gap that we found, and we found a great opportunity to develop the UF7. A standard in industry is that when you have fine or when you have material that has high fines and has high grade in it, you would use a similar flow sheet as you can see in this image. But what will result is that you will end up having multiple stages of the scavenger to try and recover all that material that will report typically to your tailings. But that's what we wanted to actually improve. We wanted to see if we can develop a new spiral that can reduce the amount of spirals or the number of stages that you will find. For example, in this flow sheet, you have scavenger, re-scavenger, re-scavenger, all of that being an attempt to push all that good chrome that ends up falling into your tailings. So how we approach this is that we said to ourselves, okay, we realized that the minus 75 microns still has a high grade material, but it's being lost to the tailings. How about we build a new spiral called the UF7? As you can see, the U and the F stands for ultrafine, and see if we can actually push more of that material that's reporting to the tailings, push it towards the concentrate or closer to the center column. We focused actually on determining the performance on recoveries and grade. The reason why we focus on the recoveries is that you would know that with the rougher stage, you want to focus on achieving as a high recovery, and on the cleaner stages, that's where you'll focus more on the grade. If you have a higher recovery in your rougher stage, that increases the chance of recovering more mass pull in your cleaner stages. For our test work, we used a mouth organ, and a mouth organ, you can see the image below. It has different fractions between A to F fraction. For our concentrates, we considered fraction A to C, to be our concentrate product. This is just a summary of our positive results. So like I said, historically we've always recommended the HX5 to be able to handle all these fines. So obviously we'll do a comparison between the UF7 and the HX5. So the feed grade for the material was at 13% for both of the feed that was fed onto these two spirals. And what we found is that the concentrate grade came back for the UF7 to be 25%, for the HX5 to be 26%. Again, that's quite close for us, but obviously the HX5 slightly, or we feel insignificantly, outperformed the UF7. But remember what I just said, for the rougher stage, you really want to focus more on recoveries, less on grade. You focus on grade at the cleaner stages. So we look at the concentrate recoveries. The UF7 was able to achieve 28% and the HX5 was able to achieve 15%. And that has resulted in 13% improvement between comparing the HX5 and the UF7. So clearly the UF7 has outperformed the HX5. We look at the concentrate mass yield. The UF7 achieved 15% and the HX5 achieved 7%. And for us, that was so significant because again, in industry, it has always been so hard to push all that ultrafine material that's been lost to your tailings, pushing it back into the concentrate. So this is just a graph just to emphasize or to be able to see the difference between the recoveries. So you have the gray line, which is the UF7, and the blue line, which is your HX5. For the concentrate, you see that the UF7 line is above the HX5. And you can see the gap between them, that there is a significant difference between the recoveries of the UF7 and the HX5. When we look more into detail, what you see on these recoveries for chrome specifically is that, okay, so the UF7 is the orange and the HX5 is the blue. What we see at H fraction, our H fraction will be where we'll find most of our tailings, is that the chrome material in the UF7 is quite low in comparison to the HX5. So we thought to ourselves, okay, with those tests being positive, what can happen with other different clients' material? So we have client AA, BB, and CC. So we'll see that with client AA, it had a feed grade of 30%, and the concentrate recovery went to 36%, and for client BB went to 24%, to client CC to 28%. What this was an indication for us is that the UF7 is not necessarily sensitive to the type of chrome that it can feed, but it actually will improve concentrate recoveries regardless of what kind of material or what kind of chrome material is being fed on this UF7. So what are the applications for the UF7? So when plants or anyone in industry has struggled to process these tailings or these ultrafine material, they have resulted in considering using shaking tables, WIMPs, or reflux classifiers. We see the UF7 as an opportunity to work concurrently with all these other equipment or somewhat maybe replace them. But again, I repeat that great results were shown for specifically minus 75 microns. What are the benefits of the UF7? So the UF7, again, can treat all the ultrafine material. It is a great opportunity to retreat your tailings dams. It has improved recoveries in your rougher stages, therefore will produce higher mass yields in your cleaner stages. And again, a spiral has no moving parts, no chemicals, so it is cost effective in comparison to all the other technologies that you can consider to process ultrafine material. So further developments that we are currently busy with for the UF7 is to check if there's particle size sensitivity. One thing we know for sure is that the UF7 can handle minus 75 micron, but now we want to test what is the particle size limit. We want to test all the other heavy minerals, and we want to see what type of flow sheet will actually work for UF7. So currently the test work that's still underway is that we are busy testing a full flow sheet that you will find at a plant that consists of roughers, scavengers, mix cleaners, and so forth. So again, I say the approach that we're using is as significant as you'll find at Apple, where we believe that our products need to continuously improve. Even though we believe in the performance of the UF7 right now, we still believe that there is other changes that we can make on our UF7 to produce even better results for our client. So hence why we still say, please be excited for what's still to come for the UF7. Thank you.